Welcome. Hello, everybody. Welcome to today's webinar, The Future of Substations, Transforming the Energy Industry with Zenon. My name is Dejan Sršen, and I'm a sales engineer at Elektrodistribucija Ljubljana. Let me present our today's speakers. With us is also Dalibor Bobic, our sales engineer in Belgrade. And the most important speaker today, Marko Gostovic, from Powergrid Engineering, also from Belgrade. So let's go through introduction. So for those of us who are joining us for the first time, we'll go briefly through company profiles. Then I'll explain our basic solutions in substation automation. Dalibor will then take over and go through new features in new version Zenon 14. He will also present some application sets and demos where you'll see some nice solutions and samples that can make a foundation of your Zenon project. And then, of course, the most interesting part, our real-life use case from 110 kilovolt substation in Serbia. After Marko's part, we'll go to Q&A session, where we'll answer your questions, which you can, in the meantime, write into our Q&A box and chat box. Okay, Elektrodistribucija is present in the southeastern part of Europe, so we have offices in Ljubljana, Zagreb, and Belgrade. We offer consultancy, technical support, trainings, and we are also representative for different innovative software and hardware providers and manufacturers. And today we'll speak about Zenon software, which is produced by Copa Data. So Copa Data is headquartered in Salzburg, and we develop only software. So now 400 employees are working on Zenon software. We have 450 members worldwide as machine builders and system integrators that use Zenon software, and over 5,000 successful customers. The business is still family owned, so we try to be the most hardware independent and flexible solution on the market. We, together with Copa Data, we also offer professional services for some custom development needs. Okay, you will see us post and talk about solutions in different industries as well. So we are also present in pharmaceutical industry, food and beverage, automotive. But today, of course, we'll speak only about solutions in energy industry, which is very specific industry by itself. And in this field of energy industry, we provide many solutions. So if we go on the top right, so here on the energy production from renewable energy sources, electric energy production from renewable energy sources, we can provide local HMI and SCADA. So for local control, with our Zenon process gateways, we can offer connectivity and RTU functionality with superordinate systems, and with our native Zenon native Zenon logic, which is our soft PLC, we also provide possibilities for power plant control. So you can have power plant control, local control, and connectivity with superordinate systems, all in one platform. In industrial company situations, projects, facilities, we also offer energy data management system. You can create all package in one solutions. So I'll talk about more briefly that on the later slides. We also have OCPP driver to exchange data with charging stations. We have also many references in hydropower plants, and so on. But today, of course, we'll talk about solutions for substations. So let's dive a little bit deeper on this topic. So in Slovenia, of course, we have a high voltage from 110 to 400 kilovolts. But anyway, I'll briefly talk about references that we have in substation automation. So for transmission system substations, we have references in 11 ENTSO-E members on high voltage. So here we talk about the highest availability and security needs, because we're talking about the most critical part of energy infrastructure. We also have many references for in distribution. And in industrial substations, you can also include other systems, other processes. So you can have some vertical integration in terms of energy data management, utility supervision. You can include your solar power plant besides having a industrial substation. So you can have one platform solutions for your entire facility. We have also references in railway substations. We have them in Norway, Austria, and Romania. So these are quite the different philosophies of railway electrifications. So Zenon can handle all these different particularities. And for offshore substations, we have many references in northern part of Europe. Here we need also solutions for remote access, which can be realized with our HTML web clients. So you can have also remote access to your Zenon solver, which is on the location. So as you know, the substation consists of primary equipment, secondary equipment, but then we need something for local control level. So with Zenon, you get your HMI, your SCADA, your possibility of data concentrator, process monitoring automation, and with our Zenon process gateways, we can also fulfill the role of remote terminal unit and accept commands from DMS systems. So let's go more in detail about what Zenon itself offers. So we offer seamless server redundancy, which is our native proprietary solution. Topological model with our automatic line coloring, safe switching operations we offer with our integrated solutions for command processing and command sequencing. These are all topics that we go through in our trainings. You can read more detail about them on our web page. And of course, we have all native Zenon drivers to communicate through all standard energy protocols, namely 61850, 6870. So we have drivers for, of course, for 61850, and driver and process gateway for protocol 6870. DNP3 is more popular outside Europe. We can connect also with our other native Zenon drivers, which are more used in industrial automation. And with our syslog process gateway, we can be a syslog client. And with our SNMP driver, we can exchange data with SNMP agents. So we offer a complete situational awareness with our single line diagram and solution for alarming. So we can send you notifications through SMS, through email, all with our integrated Zenon services and modules. And consistent traceability. So our secrets of event list is our chronological event list, or also if you want to call it, audit trail. So we have a complete traceability here, and we offer process replay with our process recorder. And with Zenon Historian, we can sample data on cyclical basis, on event, and so on. And with our Zenon redundancy in Zenon network, you never need to fear about any data loss. So we can parallelly store and archive all data from the process. I don't have any slides for cybersecurity, but this is a separate topic on itself. But briefly, we have all certificates of conformity with all standard security, security standards. So we are talking about IC 62351, IC 62443. We also have role-based user administration, and all communication through our internal Zenon network is encrypted. Okay, I hope I warmed you up, everybody. So I'll now transfer the word to Dalibor, who will present us new energy features in Zenon 14. So please, Dalibor, take over.
Thank you, Dan, for this first part. It's always amazing to see how Zenon is flexible and versatile and how it can be integrated in so many solutions. So let's continue with some of the, let's say, most important energy features in new version Zenon 14 that came just a couple of months ago. First of all, I would like to emphasize the mission of Data and also Exoreti. We are supporting energy companies with the vision and helping energy companies to implement solutions for next generation energy grid. Zenon is a big part of reinforcement and expansion of the grid, digitalization and modernization of grid, integration and operation of distributed energy resources. Also, interdisciplinarity and hybrid solutions for Zenon are native solution. Leveraging resilience and reaching the sustainability goal is also a very important thing today. Let's speak just briefly about general improvements. For those who are already using Zenon, this can be really interesting since automatic chronological sorting of new alarms in the alarm list are now included, and also direct filtering in alarm and event message lists are now supported with combination of filters in multiple columns. With the general improvements also, there are several improvements with extended trend manager, like dialog for selection of archive values or enhanced configuration for file-based export. Very important topic is always GIS or geographical representation in the project, now improved related to the GIS displays, which include numerous display elements in conjunction with dynamic coloring, which is very important when it comes to energy grid or renewables like this solar PV overview like we see in the screen. Regarding topologic processing, automatic line coloring and ground fault detection are really improved, which increase situational awareness due to better indication of possible fault areas, including ALC sources, new source and status, and dashed representation for each source. We always speak about HTML representation and HTML visualization, web visualization. There are several improvements now. Extended command processing support is there with several new commands for web options, which enable safe operation of substations even in HTML5 web clients. Zenon Worldview is also available in HTML5 visualization now with zooming, scrolling, decluttering, which are really useful functionalities which our users are used to in standard visualization, now also available for HTML5, also with different screen types and different supported features. In equipment model screen, now searching for equipment is available. I chose several web visualization screens, let's say screenshots from the projects. In this example, you can see the battery storage system, battery energy storage systems visualized through the web browser. So this is HTML5 based visualization from Zenon. The same goes for solar PV visualization in HTML5, really nice graphic and nice overview. Transformer condition monitoring screen from Substation HMI is also available in HTML5. You can see through browser. Wind farm overview, really nice interface, nice overview, also included now in HTML5 version out of the box. Regarding efficient engineering, now the process gateway configuration is integrated, like importing of external or legacy process gateway configuration into Zenon directly. Single line diagrams now with graphical identification of main ALC elements, which is simplifying engineering of detailed single line diagram overview. Smart objects are introduced several versions ago, several years ago, and it's constantly improving. And now the biggest improvement is supporting of distributed engineering or multi-user engineering available for engineers working on the same smart object. And variable mapping, applying variables, variable mapping configuration related to all smart objects in the project. We mentioned the connectivity possibilities in Zenon. More than 300 drivers and native communication protocols are there, and constantly improving, like Modbus energy, which is really important nowadays, especially for renewables and the communication between substations and renewables, and also DMP3, which is not so much used in our region, but we can see some applications also with DMP3. I must mention OPC UA Process Gateway, which Corpidata successfully passed the certification test, which was done last year, at the end of last year. And also very important is the process OPC UA Process Gateway is now available for Linux, providing data from the Zenon historian to OPC UA clients. Further improvements and further improvements in Zenon 14 are available in release notes. It is available in the Corpidata website. Mentioning Linux in Service Engine, here is the list of currently available drivers and process gateways, and this list is constantly expanding, and further developments are already scheduled, and we are expecting more and more drivers and also other Zenon features available for Linux Service Engine very soon. Now, let's go to the front end. Let's speak about what we can really see using Zenon in real projects. Corpidata is providing us with the application sets and different demo projects. The system integrator and especially end customer can benefit from domain-specific samples showcasing how Zenon can be smart and ergonomic in the solutions they need. Those template projects and demo projects are best practice implementation, and also provides system integrator with additional reusability, partially or fully in the projects, and also end customer can see with demo project, can really see how the power plant or substation can look at the end of the project. Let's start with substation, which is main topic today. Substation automation demo and template project is available, featuring dashboard, single line diagram with topological processing, switching commands with command processing, also different device templates, alarms, sequence of events, reports, and different things. I mentioned already that it's HTML5 ready, so it can be used also with the HTML5 clients. The main highlights of the new version, new demo version, also those demos and template projects are constantly improving. Transformer condition monitoring screen is now included with the observation of crucial transformer values such as temperature or dissolved gas analysis. This is important for full situational awareness. Highlight number 2 is functional prototype of automatic voltage regulation to compensate voltage fluctuations in distribution grids. And this is really important to see how Zenon can be used in this direction. Worth mentioning here is solar PV template and demos application set with the full plant dashboard, solar heat map, geospatial overview, and with detailed inverter monitoring, alarms, communication network monitoring, and so on. Also available for HTML5. The new version highlights is integrated web widget, Meteor Blue, the meteorological service that can be integrated into project directly, and also extendable display for performance reports. You can see some examples in the screen. Furthermore, the more and more popular topic in our region is also battery storage systems. There is also a demo and template project available featuring dashboarding, state of charge, battery management system, and power conversion system monitoring, balance of plant, and etc. Also available for HTML5. The highlights of this version is now hierarchic navigation via equipment model, and it has display structure for network monitoring, like using it in SNMP driver. So this is briefly regarding my topic today, and now, of course, as Dan mentioned, probably the most important today, the reference from Powergrid Engineering. Marko will show us 110 kV substation in distribution company in Serbia. Marko, welcome, and please take over.
Hello, everyone. Good morning. Welcome to this presentation. Thank you for joining us. My name is Marko Gostovic, and I am from Powergrid Engineering, and I'm one of the company founders. Today, I will present our experience and approach in delivering reliable solutions for critical energy infrastructure, particularly focusing on SCADA system using Zenon platform. Before we move forward to the substation implementation, let me briefly introduce our company. So we are an engineering and consulting company specializing in delivering reliable and proven solutions for electric power systems, transmission, distribution utilities, and industrial facilities. Powergrid Engineering was founded in 2023 in Belgrade, Serbia, and is 100% privately owned. Even though we are young as a company, we have respectable personal references. Our team consists of experienced engineers positioned to cover all the most important aspects related to the delivery of critical energy infrastructure projects. There are a total 5 of us, and we have been working together for almost 15 years. Our core expertise is in areas such as relay protection, SCADA, HMI systems, substation design, and power system analysis. And we work across various industries, including generation, transmission, distribution, and industrial implementations. So in Powergrid, we strengthen our capabilities through the strategic partnership with leading global companies. One of them is definitely Copa Data. The other one is SEL, a respectable manufacturer of relay protection and automation system. And these partnerships enable us to provide state-of-the-art solutions that make electric power systems safer, more reliable, and more economical. Now, let me say a couple of words about our experience. We have been part of many different projects in the past, both in Serbia and abroad, with over 65 high-voltage substations, 80 medium-voltage substations, and numerous power plants successfully completed in the past. We have conducted protection coordination studies for more than 100 high-voltage substations and roughly 10 power plants. So now I would like to focus on our experience with SCADA development using Zenon. We started our work on SCADA system back in 2010. However, this has happened with some other SCADA software, and after that, in the next 4 to 5 years, we have finalized respective number of substations that included SCADA and HMI part. As we developed as engineers, we figured out that we need much better tool so we can be more productive, efficient in our projects. So we moved to Zenon back in 2014. The main reason for such a change is already mentioned in the presentation of my colleagues. So I can only add that Zenon actually have many strengths that help us become better in delivering our solutions for SCADA systems. So with the Zenon, we have developed over 50 high voltage substations, 10 medium voltage substations, and 1 solar power plant recently commissioned. Now I would focus on substation Shabatz 1. That is one of our key projects in the last year. This challenging project required us to deliver a high level of customization and precision while finalizing this HMI. It is a large and complex facility with 6 bays on 110 kV side, 8 bays on 35 kV side, 24 bays on the 20 kV side, and 16 bays on the 6 kV side. So I will share some specific details about the project later. And here is the overview. The high voltage 110 kV side consists of 6 bays, 2 overhead lines, plus 4 transformer bays. Primary equipment replacement took place here on the 110 kV side. A new power transformer has been added and completed substation automation system. On the medium voltage side, we have 35 kV part with a new substation automation system and relay protection, but old primary equipment. And on 20 kV side, it's a brand new switchgear that also have a substation automation system included. Regarding the architecture, this is a typical diagram that best represents architecture of our system. I would say that this system consisted of 1 server and client, over 50 intelligent electronic devices, 4 Ethernet switches, GPS clock, and a separate gateway for communication with the control center. This architecture actually ensured the reliable communication both within the substation and with the dispatch center. So when we are talking about system architecture, here is a print screen of actually the screenshot of the communication diagram, so you can be aware of the number of devices that are included in this protection control system. And also you can see a single line diagram, so you can have a clear picture of substation size, composition, and complexity. Here we have a couple of specific requirements. You probably noticed that the appearance of this SCADA and HMI is not very comprehensive and does not follow the visual standards that we have seen nowadays. This is because of the specific requirements of our customer, and it was their wish to replicate the non-screen appearance, symbols, and layout, while also adjusting alarm screens and minimizing user interactions. So what we did, we have replaced the screens and replicated actually so operators can feel confident in what they do. We created the primary equipment symbols to match the operator's expectations. We also adjusted the alarm screens to not only look like, but also behave as it is in very well-known applications they have. And we limited the number of mouse clicks needed for operators to reach required functions. So all of this actually reduced complexity of the system and help operators to be more familiar with their everyday operations. So some of the key challenges we encountered include managing complex topology, maintaining security and safety, and generating comprehensive reports. Some of the specific challenges are complex arrangement of the voltage levels. So we have here 4 different voltage levels. In this case, buses could be energized from different sides. To address this complexity, we implemented automatic line coloring to help operators to be aware of the voltage presence of the bus. The project also has been developing in several stages. We had to prevent maloperation during regular substation operation and keep safety on the higher possible level. So we used common processing, and also interlocking was implemented not only on the ID level, but on the SCADA level too. One of the important things that I want to mention right here is that this substation is actually partial refurbishment with expansion. So there is a mix of old and new equipment that needs to behave in the same fashion, looking from the operator's point of view. So we use different reaction matrices to unify the system outputs. Last but not the least, here I would like to share the credit for this project with my colleagues from the previous company who started this project with us. We then took over the engineering part and finalized the project recently. So the results and benefits, I would say that by using Zenon, we achieved faster engineering time. We also redeployed some symbols and screens that we used in the past that result in reduced total cost and, most importantly, with a satisfied customer. The benefits of using Zenon also included setting parameters instead of programming, leveraging template projects, and utilizing smart objects with multiple communication protocols. So at this point, in addition to the substation Shabbats, I would also like to share one recently finished solar project. It's a solar power plant Sarorsi, which is 10 megawatt plant consisting of 28 inverters and 3 substations. This project actually further demonstrates the flexibility and scalability of Zenon in renewable energy projects. The key point here is deployment of project templates that has been modified and expanded to match the exact configuration that we have in the power plant. In addition to that, we used smart templates actually for the first time in our engineering experience with the Zenon. And finally, this is a very complex project with several different communication protocols that has been used to integrate different equipment from many different vendors, such as SEL, ABB, Siemens, Schneider Electric, Sangro, and a few other manufacturers from China. So here are the examples of the screens. Some of them are part of the Zenon template for the solar PV projects. And in conclusion, I would say that our expertise in SCADA system, particularly using Zenon, has allowed us to deliver tailored, efficient, and reliable solutions for a wide range of power systems. And with this, I will finish. Thank you for your time, and I'm looking forward to answering any questions you may have.
Thank you, Marko. Thank you. That was really interesting. So we are not letting you go yet. We have some questions for you as a long-time Zenon user. So one of the questions is, you mentioned already the challenges on this project, but what was maybe the biggest challenge for you and how did you overcome it?
I would say that the biggest challenge, first of all, I would like to say that I was not a developer of this application. My colleagues did it, so I can only say instead of them. But I believe that this project is actually one of the substations with a very complex topologies, certainly one of the biggest one that we have been involved in. And integration integration of new and old equipment, and actually dealing with the complex topologies and short time for implementation would be the biggest challenges. And actually, the Zenon helped us a lot, mainly with the some tools that helped to replicate the existing screens, the existing parts of the screens, like a base or complete control items. So I would say that dealing with Zenon actually very improved our total efficiency. That would be my answer, actually.
Great, thanks. And maybe one question: when you encounter existing systems, equipment, when you have let's say a brownfield project, what's your experience here? How does Zenon connect with these different, maybe older systems on site already?
Okay, well, we all know that Zenon is actually a very powerful platform. And as you both mentioned, there is a large number of protocols. I would say that ability to work with a variety of communication protocols and legacy system and drivers would be one of the strengths that I would like to emphasize here.
Good. And when you have to expand your projects, what's your experience here when you choose to use Zenon?
Okay, so let me think a little bit. Zenon, the Zenon platform has a very well-known scalability, so it's really easy to expand first in the number of tags that is available, and then you can accommodate with a different how to say with the different configurations of the system. Like you can use HMI client and server on one machine. You can decouple them. You can have a redundant server. You can add more communication channels to the different layers of the control centers. So I would say that scalability is really important, and Zenon provides that for companies that are in business like we are.
Okay, thank you. Yes, we try very hard. So thank you, Marko. Thank you for joining us. Thank you also to Dalibor, and I will just at the end invite you to also join another webinar in 3 weeks' time, Digital Substation Automations, Latest Insight, where presenters will be our colleagues from Copa Data, Jürgen Resch and Stefan Pufenagel. Please also visit our YouTube channel, Elektrodistribucija, where you can see our previous webinars. We have some tutorial videos, tips and tricks. And this webinar, of course, will be also posted on our YouTube channel. Don't forget to fill out the form at the end, so we can get some feedback from you and make even better webinars in the future. And if you have any additional questions, don't hesitate to contact us. If you want to contact our colleagues from Powergrid Engineering, you have their email address here, or us at Copa Data and Elektrodistribucija. Thanks again, everybody, for joining us. We hope it was a productive and well-spent time for you, and see you next time. Thanks, everybody. Bye.